Hi everyone, Miss Kilroy here. Today we're going to be doing the video notes for the first part of Physics Intro to Motion. So turn to the next blank page and on the right hand side set the page up C-note style. And then our title is Introduction to Motion. Introduction to Motion is our title. And then this is the essential question. How can we tell if something is moving? So in all of these pictures, you can tell that the object is moving, but they're still images. So how can we tell that they're moving? So just kind of think about that as we go through the notes. Remember, if I'm ever going too fast, feel free to pause and write down the information. Also, be sure not to just write down the information, but you also really need to listen to me because I'm going to be saying stuff that isn't written on the PowerPoint. For example, the title of this page is Introduction to Motion, and this is the central question. All right, here we go. So the first thing you want to write down is motion, which is the change in position of an object over time when compared to a reference point. So this is a bunch of pictures of the same motocross guy put together. So at first he starts to the left of the big ship. At his highest position, he's like at the right of the ship, and then when he's down, when he's finished the jump, he's way to the right of the reference point. So we can tell he's moved, we can tell the motocross guy was in motion because he changed positions, he changed locations. First he started over here to the left of the boat, and he ended to the right of the boat. So we're comparing his motion, his location to the boat, which is going to be our reference point. We're comparing it to the reference point. So for example, the runner, you can tell he's moving, he has moved, he is in motion because in this picture he starts at the second cone, but in the second picture he's at the third cone. So the cone is our reference point. So in the first one he's at the cone, second one he's in front of the cone. So we can tell he has moved. And then the reference point is the object that appears to stay in place in relation to the object being observed. So the reference point can be moving. It just looks like it's not moving when it's being compared to an object that's moved. So here again, the cone is the reference point. And here I want you to watch this video and figure out what the reference point is. How can we tell this thing is moving? So we never see the cat move, yet he's getting closer and closer to the camera. We can tell he's moving, but we don't actually see him move. Ah! So here in this example, we could use the chair as the reference point. So in the beginning of the video, he starts back here behind the chair, and as the video goes on, he gets closer to the chair, and then he passed the chair. So the chair is not moving, and we're using that as the reference point. Speed, the rate at which an object moves, i.e. how fast it's going. So we're familiar with speed in a car when we're looking at miles per hour. Here are some formulas you need to write down. So the S stands for speed, D stands for distance, T stands for time. So if you're given distance and time, you can find the speed. Speed equals distance divided by time. And here are some speed units: meters per second, miles per hour, kilometers per hour. If you're given the speed and the time, you're able to find the distance. Distance equals speed times time. Distance units: meters, kilometers, miles, feet, inches, centimeters. And then time, if you're given the distance and the speed, you're able to find the time. Time equals distance over speed. So hours, minutes, seconds could be your units. And here's an example, sample problem. If a car travels at 500 kilometers in 5 hours, what is its average speed? So yes, you do need to write this down. If you're running out of room, you can move on to the next page on the right-hand side, set it up C-note style. So we're going to use the four-step method, kind of similar to our density problems. First, you box what you know, and it's asking us to find the speed. So we know the distance is 500 kilometers, the time is 5 hours. Our second step, we write the formula we're going to use. We have to write down speed equals distance divided by time, plug in our numbers, and we get a final answer of 100 kilometers per hour. Okay, these are called motion diagrams, and I'm going to go over an example in another PowerPoint. So just don't write anything down at the moment. Let me just show you some examples. Okay, so when you're doing motion diagrams, here's an example. Our reference point is Sully, the blue monster, and he's moving at a speed of 18 meters per second going to the right. Now when you're moving, like when you're in a car, you don't feel like you're moving. Like when a tree passed by you, you think the tree is moving. You don't really think that you're moving. You just see the tree pass by. So the same kind of scenario here. He doesn't think he's moving. So if an object is going the same direction as the reference point, and it tells us what our reference point is, if they're going the same direction, Boo and Sully are both going to the right, we're going to subtract. So Sully thinks Boo is traveling at a speed of 11 meters per second. Because 18 minus 7 is 11, he's going to pass her and he has to look back at her to the left. So he thinks Boo's going at 11 meters per second to the left. Now if an object is going the opposite direction as the reference point, you add. So I forget her name. So the slug is going the opposite direction. She's going to the left and he's going to the right. We're going to add our speeds together. So kind of like when you're on a freeway and someone's coming at you the opposite way, it seems like they're going extra fast because you're adding your speed plus their speed. So Sully thinks the slug is traveling at 21 meters per second. He's going to pass her and look back this way at her to the left. And then Mike, he just passes Mike and you just add the speeds, 18 meters per second. He's going to pass him and he has to look to the left. So here's another example I want you to try out on your own. Go ahead and set it up kind of like this. Guess that's good. So first one, Katniss will be the reference point, and we're going to be looking at the relative speeds of Peeta, Rue, and the Mockingjay. And for the second example, Perry will be the reference point, and we'll be comparing it to Dr. Doofenheimer, I think his name is, Phineas, and Isabella. Okay, so if Katniss is the reference point, Peeta's just laying there hurt, so she's going to pass him, and you just add the speeds. So if we're Katniss, we think Peeta is moving at 25 meters per second to the left because she's going to pass him, have to look back to the left at him. The Mockingjay is coming right at her, so we're going to add the speeds together. So she thinks the Mockingjay is traveling at 65 meters per second to the left. And then Rue is going the same direction as Katniss, So we're going to subtract. So 25 minus 15 gives us 10 meters per second. So Katniss thinks Rue is traveling at 10 meters per second. And then the direction's kind of tricky. So because Rue is going slower than Katniss in the same direction, we know Rue will never catch up to Katniss, right? Just because of their speeds. So for that reason, Katniss will have to be looking back to the left towards Rue because they'll be getting further and further away from each other. So Katniss thinks Rue is going 10 meters per second to the left. Okay, let's try the next one. Okay, so Perry the platypus is the reference point. In comparison to Phineas, different directions, so we add. So Perry thinks Phineas is traveling at 17 meters per second to the left. Isabella's going opposite directions, so we add. So Perry, in comparison to Isabella, thinks she's going 21 meters per second to the left. And then Dr. Doof, blah, 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 and Perry, they're going the same direction. So Perry thinks he's going 19 meters per second to the right because he's going to pass Perry, and Perry's going to see him get further and further ahead of him to the right. All right, I hope this helps. This is the end of our notes. If you need to go back and review anything, go ahead. Also make sure you wrote down all the stuff in white from the previous PowerPoint. And then I did want you to write down this information too. You didn't have to draw it, but I just wanted you to write down the answers. So when you're writing down the answers, for example, with Perry and Phineas, you'd write down 17 meters per second, meters per second to the left. So you could use an arrow or you can say it out like that. All right.